Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about velocity in two dimension for NEET and JEE. First of all, I will discuss the theory in a brief manner. After that, I will discuss about the problem. Okay. So, if a body is in motion, its position changes with the time. If a body is at rest, its position does not change. So, based on the position changes or not, we can say that the body is in motion or rest. In a plane, that is in the two-dimensional motion, by using the position vector, we can specify the position of an object. So, what is position vector? We will see first. Okay. Position vector is a vector which specifies the position of an object. This is the x-axis and this is the y-axis. Consider a point here. This is the position of an object. Okay, I need to specify the position. So, there is a vector you can draw from origin and towards the point P. This is the position vector of the point. This position vector says that the object is from origin towards this point in this direction with this much distance. Okay, so the R vector specify the position of an object. Okay, if the position changes, we will say that the body is in motion. Okay, now you see x, y axis. The body is moving like this. Initially, I consider point P1. The position vector of the point P1 is R1 and the position vector of P2 is R2. So initially the body is at P1 point. After delta t time, after a small time, the body is at point P2. Okay, so now you see that the position changes, the body is in motion. Initial point position vector is R1 and the final point position vector is R2. We will see the displacement. Displacement is always the shortest distance between initial and final position. So, if we draw a straight line from initial point to final point, that is the displacement. Here, we will consider the displacement vector. So, displacement delta R is equal to, we have to find it. Okay, so from the triangular law of vector addition, I can say that R1 vector plus delta R is equal to R2 vector. From here, delta vector is equal to R2 vector minus R1 vector. This is the displacement. So, displacement is equal to R2 minus R1. What is R2? R2 is the position vector of the final point. What is R1? R1 is the position vector of the initial point. So, the displacement is the difference between the final point position vector minus initial point position vector, and the direction is always from initial point towards the final point. Okay. Then here this body changes the position in the delta t time. So amount of displacement in unit time is called as the velocity. Average velocity is equal to the velocity in a particular interval of time. Here we are going to find out the velocity in a delta t interval of time. So delta R is the displacement in that interval of time divided by the delta t. Here delta R is a vector quantity, that is a displacement. So the velocity also a vector quantity. So the magnitude of the velocity can be found out by like this, delta R divided by delta t. What about the direction? You see this, the velocity have the same direction of displacement. So the velocity direction, that is average velocity direction, is same as that of the displacement. Okay, then if we will consider the velocity at a particular instant, that is the instantaneous velocity. Instantaneous velocity. What is instantaneous velocity? Velocity at a particular instant. Instant means That is the limiting case of the average velocity. This delta t is very, very small. So limit as delta t tends to 0, delta r divided by delta t. Okay, this is equal to dr divided by dt. So the instantaneous velocity is equal to derivative of the r with respect to time. What about its direction? This is the thing x, y. This is the motion of the body. This is the point P I am considering. Okay, and its position vector is r. Okay, the instantaneous velocity at this point is the tangent drawn at that point. So this is the instantaneous velocity. So if we need to find out the instantaneous velocity at any point on the path is just draw the tangent at that point. Okay, that will give the instantaneous velocity direction. Okay, this is about the theory. Then now we will see the problem. The coordinate of a moving particle at any time is x is equal to a t cube and y is equal to b t cube. The speed of the particle at t time. Speed means the magnitude of velocity. Velocity is dr divided by dt. That is the instantaneous velocity. From this, r is equal to xi plus yt. Okay, then first of all we can take the derivative of x with respect to time. That will give the x component of the velocity. So dx by dt is equal to d by dt of x is how much? X they are given as a t cube. Okay, so a t cube you will get. Okay, so what about the derivative of this? The derivative of this is a into 3 t square will get. Okay, then this is about a bx. Then next we will see about the y component, that is vy is equal to dy divided by dt. Okay, what about y? D by dt of y. Y is bt. Okay, so if you take the derivative, b is a constant, the derivative of t cube is 3t square. Okay, this is the y component. So the velocity we can write it as 3a t square I plus 3b t square j. Okay, we need to find out the magnitude. So the magnitude of the velocity is equal to square root of vx square plus vy square. Vx is this much. So 9a square t power 4 plus vy is this. So its square is 9b square t power 4. Okay, from these two terms, 9t power 4 is constant. That we can take it outside. Remaining here is a square here and b square here. Okay, from this we can find out from this we can take this 9t power 4 outside. So 3t square into square root of a square plus b square. This is the speed. Okay, this is about a type 2 problem. Then next we will see the type 3. This is the type 3 problem. A bus moving on a straight road towards north with a uniform speed of 50 km per hour, then turn left through 90 degree. The speed remained unchanged. What about the increases in velocity? Okay, then this is the north, here is the south direction, here is the east and here is the west. Initially the bus is moving towards the north like this. Okay, then it turned left means this direction like this. How much turn? 90 degrees. So and then continues the path. Okay, the speed remained constant. What about the increase in the velocity? We will find out. Okay, so first of all we can draw the initial velocity vector. Initial velocity vector is towards north. This is the initial velocity vector. This is the v1. Okay, v1 value is 50 km per hour. Okay, then after that it is turned how much? Left 90 degree. This is 90 degree. This is the V2. They given us the speed remain constant. So the V2 also having 50 km per hour. Okay, we need to find out the change in velocity. Change in velocity is equal to final velocity, that is V2 minus V1. This we can write it as V2 plus minus V1. Okay, minus V1 is a negative vector. Okay, so the negative vector of V1 is in this direction, the same magnitude, but in the opposite direction. This is the minus V1. Okay, now we can find out the resultant by considering the parallelogram. Okay, so this is a diagonal of this parallelogram. This diagonal is the change in velocity. Okay, so here the angle also 90 degrees. So the magnitude of V is square root of V1 square plus V2 square. So how much you get? 50 square plus 50 square. That you will get. Okay, so this I can write it as 50 root 2 like that I can write. Okay, 50 root 2 meter per second. This is the magnitude of the velocity. What about the direction? Direction is towards the southwest. Okay, so meter per second towards southwest. Okay, towards the southwest. This is the increase in the velocity. This is the type 4. Position of a particle is r vector is equal to 6ti plus 2t cube j plus 6k. Find the velocity at t is equal to 3 seconds. Velocity is equal to dr divided by dt. So d by dt of r is 3ti plus 2t cube j plus 6k. Okay, derivative of this is 3i we will get plus derivative of this is 2 into 3t square j we will get. Okay, this is the velocity at t instant. We need to find out the velocity at t is equal to 3 seconds. Then 3i plus 6 into this t square, that is here 3 square into j will get. So 3i plus 6 into 9, 6 into 9 j we will get. Okay, so that is equal to 3i plus 6 into 9 is, that is 54. So 54 j we will get. This is the velocity at t is equal to 3 seconds. Okay, this is about a type 4 problem. Okay, that's all about the velocity in 2D.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like